Today we're doing experiment 2, laboratory measurements, all right? And really what this experiment is going to tell us is if you actually know significant figures, and if you can read these devices, and then once you have made your measurements with the devices, today we will be using a ruler, we will be using a graduated cylinder, a balance, and a thermometer. So those are our devices. And so you will be making these measurements, and once you make those measurements, then what will happen is you will convert those to other units, and then do some multiplication and adding and subtracting, that kind of stuff. And so it lets me know, not only do you know how to read a device, but it also lets me know that you can do significant figures when you have to do mathematical operations. All right? So it's a quite simple lab, but again, it shows me if you really know what you think you know about significant figures. All right, so the first part of experiment 2, I'm just going to use the piece of paper, okay? And they want you to figure out the length of the piece of paper and the width of the piece of paper. So I have a ruler here, all right? And so I'm just going to take it and I'm going to measure the length, okay? And then what I'm going to do is I'm going to take this as well, and I'm going to measure the width, okay? Now I'm going to put that up here because I have a common problem that students encounter here. So for the length of the piece of paper, the first thing is I'm going to do it just in inches, and then you will see that there's multiple other units, and so therefore you can convert using the conversion factors that you learned from chapter 1. All right, so one of those conversion factors, remember, is 1 inch is equal to 2.54 centimeters. That is something that you have to have memorized, and that's something that you should know. And there were about 3 or 4 other ones that you should have memorized, conversion factors from chapter 1. All right, so 1 inch is equal to 2.54 centimeters. So today we're going to measure that piece of paper. What I just did was measure it in inches, and then you can convert to all the other units. All right, so the length of the piece of paper is going to be 11 inches, and the width of the piece of paper is going to be 8.5 inches. Let's write it that way. All right, and a lot of people write 11 down and then write 8.5. All right, and this is a problem for me. And the reason that this is a problem for me, quite frankly, is if you use the ruler and you're looking at this length right here and you go, that's 8.5 because it's in between the 8 and the 9, all right? You know when reading that with a ruler that there's one place past that decimal, okay? Well, if you know because the width is 8.5 and you can read one place past that decimal, then you know the length. You should also be able to read to one place past that decimal. And so it should be not 11, but it should be 11.0. And that 0.0 is a significant digit because you read it off that device called the ruler. Does that make sense? You cannot willy-nilly give me one place past the decimal here and not do it up here. If you can read it here, you can read it there. Does that make sense? Okay? So you have to write it, because if you just write 11, I don't know that you know that this has got 3 significant digits. Does that make sense? Okay. So those are your measurements for part A. So let me go ahead. That's all you really need for part A. Okay. That's all you need data-wise for part A is 11.0 and 8.5, okay, inches. Everything else you can take, can you zoom in on this piece of paper? All right, so now you have 11 and 8.5 for your length and your width. You will convert to centimeters. Once you have it in centimeters, you will convert to millimeters, and then you will convert to meters. Okay, so once you convert all of those, then you will calculate the area of this piece of paper. And remember, for calculating the area, you just take the length times the width, and then you will put that value on that line for inches squared, centimeter squared, and millimeter squared. There is no line for meter squared. All right, so just those three. And when you're putting those values on that line, then you need to make sure that you actually use the correct amount of sig figs. All right, so that is part A. All right, now we're going to move on to part B. All right, this is a beaker. This is a Erlenmeyer flask. You will see on the beaker that you have a mark that says 50, and you will have a mark that says 50 on the on the Erlenmeyer flask. So what we're going to do, we're just using water today, so I am not going to be wearing my goggles. Okay, I'm going to be pouring 50 mils of water in, and when you do, then you want to make sure that you're reading it exactly right, and if you're close, you want to be always at eye level, and you want that to be 50, okay? Okay, looking good. So now I'm going to put 50 in the other one. So I have 50 mils of water in an Erlenmeyer flask, and I have a 50 mils of water in a beaker. And so you will notice there's not very many hash marks or lines on a beaker or on an Erlenmeyer flask. But if you look at a graduated cylinder, you will see that there's more hash marks, which means this is a better measuring device. All right? So what we want to know in this part B is we want to know, is the Erlenmeyer flask or is the beaker a better measuring device? We all know that this is your best measuring device. Okay, that goes without saying. But we want to know between these two pieces of glassware, which one is going to be better. So we measured out again 50 mils of water. So now we're going to measure it. Okay, making sure every last drop comes out. So I put the beaker value here in yellow, and then I put the Erlenmeyer. 1. I want to make sure I get every last drop out. Okay, and now if you could come over here, sweetheart. And now you should be able to read these devices. I don't know if that. Okay, I don't know if you can do that very well. Okay, I'll write it down for you as well. Okay, but I'm going to give you a moment to read it. So again, each of these devices had 50 mils of water in there. So when I read the Erlenmeyer, I have 47.2 milliliters. And then when I have this one, I have 44.5 milliliters. Okay? So you should be able to, again, show them the view, the side view. You should be able to read one place past the decimal in this device. Again, if you say that it's a 0, you'd be wrong, but that's beside the point. You have to put that .0, okay? You need to be able to read your device, and these graduated cylinders will give you one place past. All right, so in this part B, they want you to convert to liters. So you'll just take your milliliters and convert to liter. And then what you will do is that you will find the error in the volume. So it's supposed to be 50 mils because we put 50 mils in here, correct? So the error for this first one is going to be 2.8 mils because 2.8 plus that equals 50. And then this one will be 5.5 error. All right, now you can figure out the percent error in each one of these, and once you figure out your percent error and you do that with the correct number of sig figs, then you'll be able to tell me whether the Erlenmeyer flask is a better measuring device or if the beaker is a better measuring device. That's part B. Let me turn on. We're going to turn on the balance, so you're going to want to come over here and take a shot of the balance if you don't mind. Okay, so in your tutorial labs, you used a balance. Obviously, it was by the web. So you always make sure that you measure out. Okay, you tear it out to make sure that it's 0, so that you would only be getting the mass of your object. All right, so the first one they say that you want the mass of, and you look at the units here. Do you see how the units are grams? Okay, you can change those on most scales. So for our scale, we have grams reported here. So we're just going to take our data and we're going to put it right here on this line. Now the first item is a quarter, and I don't really have a quarter, so I'm going to put 2 pennies. All right. So I'm going to open up the sides. I'm going to stick those 2 pennies on. And remember, I've already teared it out, so it was 0. And the mass of 2 pennies, which we'll just say is a quarter, is 5.647. Do you see how you get 3 places past the decimal on that balance right there? So you don't get to like choose, well, I'm only going to record 1 place past the decimal. If this device gives you 3 places past, then those are all significant. All right, and so that should be what you write down on your piece of paper. All right, so then the next one that they want you to use is one of these little baby test tubes. So we're going to take that and we're going to put it right on there. Before we do that, let's just make sure we tear it, just make sure. It was 0, but we just want to be careful. All right, and so the value of that test tube is 8.668 grams. And so we will take that up, and we will close it, and we will tear it one more time. And then last but not least, it asked us to do an Erlenmeyer flask. So we're going to take this Erlenmeyer, and I chose a new one because the other one has water inside. So I just want the mass of this. And so then I'm going to close that, and that's going to be 97.430. Okay? And so that is the mass of the Erlenmeyer flask. So if you took a picture of that. So now since you have all 3 of those values, then they just want you to convert to milligrams. Okay? And be able to do that in milligrams. All right, so we have one last part of this experiment. And the easiest way to do this is just to take the temperature. So we'll give you the temperature in Celsius. Okay? So you'll see this is going to be your temperature in Celsius. So we're just going to turn on this deionized water right here, and then we're going to run it, and we're going to take the measurement of just the water temperature. Okay, so I'm recording 22.0 for room temperature water. So 22, we'll go and we'll use 22.0 since it was that way. So let me turn that on. So we will use 22.0. All right. So then we will choose cold water, okay? And then we will put this in running cold water. Actually hotter than the room temperature stuff. That's crazy. Oh well. It's our data. So we'll just give it a couple minutes. So we'll go to 23.4. Okay, so the cold water would be 23.4 degrees C. And now we're gonna turn on the hot water. I gotta wait for it to heat up. It's getting slightly warm now. I'm going to start putting it in here, but it's probably going to be a second before it heats up. Okay, so we'll just call it at 33. Because it's just warm. So we'll call it at, just keeps going down now. Oh, it's not even hot anymore. Well, the hottest that I saw it get on this thermometer was 33.1. So we'll go with 33.1 because now the hot water's not hot anymore. Right? So we'll write down 33.1. Okay? So that's your measurements for temperature. So we just took room temperature, which was kind of low, and then the hot tap water, and then the cold, and it's kind of only slightly warm. So if you'll take these measurements and convert to Fahrenheit and then convert to Kelvin, you can show your work down here. All right, and so that's all of your lab data for the lab this week. Remember to also do the pre-lab, and then I think there's like 6 questions in the post-lab. So then upload all 5 pages of the report sheet onto Moodle, and then I will grade that for you. All right, and as always, if you have any questions, please just let me know.